This is Retro Shaders Pro, and in this video I want to go over the features of this asset pack. In the root folder, you'll see the README, which contains a list of all of the shaders and effects and demos and everything in the pack. This also has my contact details, so if you encounter a bug, or if you have a feature request, or honestly if you've made a game with this pack, feel free to reach out on that email. I am always looking forward to hearing from you. And of course, if you have problems, I'd rather hear about it here so I can help fix your problem, rather than find out through a negative review, which has happened before. And of course, if you like the pack, then do review it on the storefront that you bought it from. I would massively appreciate it. It really helps. If you downloaded this pack from the Unity Assets store, then you can install it through Window Package Manager, and you should find it in the My Assets section. If you downloaded it from itch or any other storefronts, then you will have to right-click in the product view and go to Import Package, Custom Package, and then find the Unity package file that you downloaded. Without further ado, let's get on to the stuff in the pack. This is one of the demo scenes contained with the pack. It's just an outdoor scene. It's got a few meshes and a terrain, and this is to show off the fact that you can use terrains with the pack. And the other primary demo scene is this city block scene. The purpose of this scene is to show off the support for additional lights. In fact, this is the best place to show off one of the major features of the pack. If I go to my renderer, you'll see that we're using the deferred rendering path. This pack does support all three major rendering paths in Universal Render Pipeline. But when you first download the pack, you're probably going to be using forward rendering, and you'll see these artifacts on the floor from the lighting. This is because there is a limit to the number of additional real-time lights that you can use in forward rendering. If you use forward plus or deferred, you might need to recompile the shaders. It just might take a while. Everything will appear sort of cyan for a bit. You'll see that those artifacts do disappear. So just bear that in mind if you use a lot of additional lights in your scene. Now let's see what the major features of the Retro Ilett shader are. So for this, I'm going to pull in a couple of prefabs. And it's going to recompile these shaders because I changed the rendering path. I'll give it as forward plus for now. Find the material for these. So this is the Retro Ilett shader. By default, it uses kind of the features you would expect for a PS1-style object. The Retro Ilett shader supports many of the main features that you'd get in most lit shaders. Stuff like opacity, transparency. You can select which faces are rendered. So if I only render the back faces, it looks weird, of course, here, but you can do that. And alpha clipping. So if I enable alpha clip, I think if the threshold's 1, it's going to look kind of weird and probably have Z fighting, but yeah, there we go. If I decrease that, because the alpha of my audit is quite high, if I reduce that, then the audit disappears. But I'll disable alpha clip. Let's move on to the retro properties. So we have a base color and base texture. That's just the albedo, what you expect from a base color. Next, we have the resolution limit. So this works on mip maps. So you will have to have mip maps enabled, on your texture that you're using. And because this works on mip maps, it will snap to powers of 2. So if I were to reduce this, you'll see immediately after I went down to 64, which is the power of 2, it jumped to a next resolution value. If I go below 32, it will reduce again. So you can do that. Of course, a lot of PS1 games and retro games in general had quite low texture resolutions. We got the snap per meter next. So each Unity unit is 1 meter across, and the snaps per meter is how many snapping points for the vertices of your mesh for each meter across this grid. So if I were to move this, it's currently at 64 snaps per meter, so if I move it slowly, you'll see there is some snapping. The vertices don't snap to the bounding box of like the collider I've got here. And this snapping actually operates in view space, so if I rotate my camera, it will also snap. If I find that material again, I can turn this down to something ridiculously small like 16, and now we'll see the snapping's a lot more aggressive. But I'll keep that at 64 because it's a lot more natural. Next we have the color depth. By default, most textures will have a color depth of 256 colors per color channel, or possible color values. And this is a limit, so the color will snap to like the next lowest value here. So if we restrict it to 32 values, we'll only have 32 possible colors per color channel. So that's like 32 times 32 times 32. Still quite a lot of colors, but we can turn this down to something much lower, like 16, and you'll see that the color option, the color values, the number of possible values is restricted. We also have the color depth offset, and I've got this because when you do this color depth, well, it's posterization or posterization. When you use that, it will snap down to the next lowest possible color value, and this offset allows you to kind of raise, like between the lowest and next up color values, just because when you do this flooring, it tends to darken the object. Next, we have the affine texture strength. Now, affine texture warping is one of the common effects you see with PS1 games, because the hardware couldn't do perspective correction with the UVs. You would get this warping effect. If I put this to 1, this is the warping that you would see on this mesh in a PS1 game. If I turn on my shaded wireframe here, you can see that this triangle takes up a lot of the screen and it warps a lot. But one of my one user request was the ability to turn this down, because real developers would subdivide meshes in order to mitigate this effect. But that's quite cumbersome to do for every single mesh in your game. So instead, I have a slider where I can turn this effect down, and it will only be half as effective if this is 0.5. If I turn this to 0, this is a perspective correct mapping, as you would expect from a modern graphics hardware pipeline. So, yep, there's a slider for that. Next we have the point filtering. If your texture uses bilinear filtering, you can force it to use point filtering instead, which is nearest neighbor interpolation. So you get this blocky appearance. When that's turned off, it will need to recompile. Which sometimes takes a while. Yeah, it's slightly blurrier. I'll turn that back on. And lastly, we have enabled dithering. So I've had dithering on the whole time. It's this sort of like blotchy sort of effect that you see when you use color depth. And this is basically blending somewhat between one color depth value and the next one up. It's intended to smoothen out the transition, because you are taking a range of, say, 256 colors to, in this case, only 16, and that can result in quite a harsh transition. So this dithering effect was used in PS1 games a lot to soften that transition, and that's another core part of the PSX effect. So it's good to have that on if you want, but you can turn it off and you just get just the posterization. It's also worth noting there are unlit and vertex lit variants of this shader. The unlit doesn't apply any lighting, as you would expect, and vertex lit will only apply the lighting at the vertices of the mesh and then interpolate the values across the other pixels in the mesh. I'll turn wireframe mode off there. Next, we have the bilinear-free versions of each of these effects. Now, with the Nintendo 64, it did a special kind of bilinear filtering, whereas in modern pipelines, you typically use 4 nib by texture values to do your linear filtering. The Nintendo 64 did only 3 points. So if I drag this on, and then wait a second, and turn the affine texture strength down a bit, With Nintendo 64 textures, you often saw that on one diagonal, the texture was quite smooth, and on the other, it's still quite blocky. I have also kept the affine texture slider on here, and this will allow you to have some kind of weird mix between like the PSX effect and the N64 aesthetic, which didn't exist in real life, but I thought it was cool to include that still. And we have the rest of the features as you'd expect, so the resolution snaps and color depth and stuff. Next, I want to cover the CRT effect that is included with the pack, so I will delete those. And let's look at the CRT filter. When you add this to a URP post-processing volume, you might see, if I go to my renderer, by default it won't be included in your renderer. So if I remove that and click back, you might see this message saying that it's not in your renderer feature list, which means that the CRT won't run. But I've added this button here. If you click that, it's going to automatically include it in whichever renderer you're currently using. So here's my CRT effect. So let's go through each of the properties here. If I go show in scene view, then this is what the effect looks like. And I have some of these properties are quite ramped up, so you can tone these down. Enabled, straightforward, does it run or not? The render pass event is important. You can either have this before or after the internal URP post-processing. If you run this before, then you might have noticed some small changes with the bright parts of the scene here. If you run it before, then the output of the CRT shader is, it restricts the range of the colors. So things like bloom, if you are also running them, which I am on this volume, might not have the effect that you want. If you run after, then it will allow bloom to happen, and then the CRT is applied to the results of the bloom. Next, we have the resolution properties. So the pixel size, we just pixelate the screen. If I turn down the random wear for a minute there, yeah, it's just pixelating the screen. But this is using bilinear filtering at the minute, so it looks kind of very blurry still. We'll turn that back down to 6. The scale of screen space property is for if you are designing your game at a certain resolution, this reference resolution, then it will automatically scale if you deploy this game to a screen that has a different resolution. So it's kind of like if you've used the Unity's inbuilt UI tools, it also has a similar kind of scaling thing. It would have scaled the pixel size and RGB scanline sizes to fit the screen size. If we click force point filtering, then that has quite a drastic effect. You'll see that the screen's now more pixelated. So that just operates on the internal texture used by the effect. And interlacing is an effect that old screens or some broadcasts or VHS tapes would use, whereby it would render odd lines on the screen on the first frame and then even ones on the second frame, and so on and so forth. So if you rotate the screen, then this becomes a lot more obvious what it's doing here. You get this sort of like jaggedy look. Real screens would use deinterlacing techniques to mitigate this, but this is what it would look like if you didn't deinterlace. If you wanted to deinterlace, then I just leave it off, and this is kind of closer to what it would look like. The distortion properties here are for this sort of barrel look. So CRT screens were commonly a big glass panel on the front, and it would look kind of rounded. And we can influence how strong this effect is. If it's 0, then there's no bending whatsoever. And we can change the color of the screen around, well, the screen. So we can make that red, so we can make that white. Usually keep it as black. The RGB effect is something I will have to zoom in on in post-production here. This overlays a small RGB subpixel texture onto your screen. And that's because on most screens, each pixel isn't just like one color that comes out. It's a mix of individual red, green, and blue parts. that look like one color when they reach your eye. And I can emphasize this effect just by increasing this. This does have a side effect of darkening the screen, which you might want. But if you want to mitigate that, I'm going to jump ahead and go to the brightness settings here, actually. So you can manually increase the brightness a little bit. I've got to reduce that a little bit and keep the brightness high. It looks a bit more sensible. If I just quickly undo all of that. And then you also have contrast, which increases the contrast between the brightest and darkest areas. This might be good if you're going for a horror game aesthetic, where you want the dark areas to look kind of indiscernible from other dark areas. And then you have these bright highlights that kind of jut out. I'll keep that as 1. And back up to the RGB and scanline section. We have the scanline texture. So you might notice there are very subtle scanlines traveling down the screen. If I increase that to 1, they become a lot more obvious. We can then control the size of both the RGB and scanline effects using this property. And now the scanlines are very obvious. I would normally keep this as a multiple of the pixel size. And then we also have the scanline scroll speed, which is how fast the scanlines are traveling down the screen. If I set this as 0, then they won't move, but this might be an effect you'd want to have. It emphasizes the difference between each line of pixels, which might be quite cool. But I'll keep this scrolling down and just turn the strength down quite drastically. Next, we have VHS effects, or artifacts. So VHS tapes are quite well known now for being poor quality, or at least they degrade a lot more than something like a DVD or a Blu-ray. The first effect is the random wear. So you'll see that the boundaries of objects here are quite sharp. If I increase the random wear, they'll start to sort of jutter around a bit. And this is the effect you would see on a VHS tape with that's quite old, it's quite low quality, it's degraded a little bit. Then we have the aberration strength. You will also possibly, if I turn the random wear down a little bit, you'll see some red and kind of blue fringing along the outside of objects here, and that's from the aberration. You can turn this down to 0. It may have to recompile the shader when you do that, because this uses a keyword in the background to process everything. Just because aberration uses 3 texture samples for the individual red, green, and blue channels, and it will offset the UV slightly the further away from the middle of the screen you are. And that's quite expensive, so if you don't need aberration, I would turn this down to 0. And you only do 1 texture sample, it's a lot cheaper. But I like to keep it a little bit higher. Next we have the tracking, and this is a little bit complicated how the texture's set up, but the red and green channels control 2 of the major sort of features of the tracking, respectively. First we have the tracking size, and this is how many times the texture is tiled across the screen. So I'll keep that as quite low. The strength is how much the UVs of the screen are distorted when the tracking bits go over it. So you'll see here is pulling the pixels to the side. I've got the speed, pretty straightforward. You might want to have that for like a rewind effect. And then there's the jitter, which you'll see it's not smoothly traveling down the screen. There's a little bit of like jumping about. If I increase the jitter, then I mean, it looks quite bad if you have it at certain values, but if you have this high enough to be slightly noticeable, but not so high that it's distracting, then that's probably a good place to have that. And that just introduces some randomness. Just because a real VHS tape wouldn't have like a smooth sort of tracking going down the screen. The color damage is an interesting effect. So internally, I convert the RGB colors to the YIQ color space, which was used by certain kinds of broadcast and VHS tapes. And then I rotate the chrominance of the image and the IEQ channels of that color space. And that's just to say the colors go weird. And this also looks like a degraded tape. Then we have the lines threshold, and you'll see some kind of fuzzy lines that appear when the tracking goes down. This threshold is sort of how likely it is that a given pixel shows up as tracking. The higher this is, the lower the chance. So if I reduce this all the way to 0, the effect is essentially white noise, so it's very likely for each pixel to get over this threshold. I like to have that quite high, so we get this sort of like liney effect. It's quite nice. And then we can change the color. Very important, the alpha component here controls the strength of the color. So I can turn this down, and now the lines are a lot more subtle. Or I can turn it all the way up, and they are full white. Or red, or black, or whatever color you pick here. So I like to keep that a little bit lower. And that is all of the parts of the CRT effect. What remains to be talked about? There is the skybots. This is a bonus material or a bonus shader that I include with the pack. And it's just a procedural clouds effect that scrolls across the world. If I find the correct one, I have one of the materials here. I can change the sky color, and I can change the ground color, which is sort of like a reflection from the ground on the clouds. And you can get quite a lot of different effects here. And this has like a resolution limit as well. I do also have a shader for if I go grab, no, it's Skybox. There is also a cube map version, which reads a cube map kind of as you would expect, and you can apply the PSX properties to it, like resolution and color, depth and everything. But I don't have any cube maps included with the pack, so you have to kind of try that out by yourself. Lastly, this pack comes with, inside the shaders retro base folder, it comes with a supplementary package that contains graph versions of each of the effects. And I've actually already extracted this because this is my development version of the pack. If I click here, here's the shader graph version. This doesn't have all of the features of the retro effect, but it has most of them. And I've included this if you want to make your own effects that use the PSX components, but you don't want to have to write shader code because it can be a little bit complicated. This, I hope, reduces the barrier to entry. This was a request by a user who wanted to make their own effects, so I appreciate them asking for this. If you import this and you see compiler errors or console errors, it might be telling you that you don't have enough variants, and to fix that, you'll have to go to, and this differs by which version of Unity you're using. If you are on Unity 2022.3, go to Preferences, Shader Graph, and increase the shader variant limit here. If you're using Unity 6 or above, it is in Project Settings, Shader Graph. I have no idea why they moved that. This is a better place for it, but that's how it is. You might have to increase that to something like 512 or above. Basically increase it until it works. And that's because I use a lot of keywords for the lighting. The problem is this is an unlit graph, and you don't get these keywords for free like you do with a lit graph. So that's why you encounter that problem. And that is it for Retro Shaders Pro. If you have any requests or feedback or any kind of problems with the pack or feature requests, reach out on the email that is included in the README. I will try and respond as soon as I can. Yeah, if you like the pack again, leave a review because it really does help me. But yeah, I hope you have a good time using this pack and are able to make great PSX style games with it. Thanks for watching.